RISAFoundation utilizes a comprehensive set of modeling tools for the simple creation of a variety of foundation elements. Model foundation elements such as grade beams, retaining walls, spread and combined footings, piles, and mat slabs. In this video, we'll demonstrate how to support a slab on piles with a beam around the edge in RISAFoundation. So let's go ahead and get started. So we've got here a model I'm looking at, and if I just show you here the rendered view, I have beams around the perimeter of my model. And I'm going to look at those beams here, and then there's the slab interior. If I unselect that slab, you can see I have just a mesh of beams, and I've drawn them supported by these piles. Those piles are just supported at the points, but they could also be supporting anywhere actually underneath the grade beams. But since we have a slab as well, the slab could also be a point of support for those piles as well. So those piles could go anywhere inside of that slab. So those piles are defined in the pile definition spreadsheet. Currently I'm using the square pile with a 14-inch side dimension there. We give the embedment here. The pile embedment is 6 inches, and then we have some of the stiffness properties of that pile. So compression capacity as well as the tension capacity, and finally the shear capacity. One thing to note when you're modeling a slab like this, so you're going to be looking at the center line of these beams. So if the perimeter of the structure was out here on the edge, it would be important for you to model it so that it has that offset slightly. So you could actually have the perimeter of the structure be represented properly. So we want to find that beam reinforcement. So I'm going to go and solve this model really quickly, and you're going to see that those grade beams there are going to be designed. If we click on that grade beam and open up our detail report, the detail report is going to give you a design here for the reinforcement as well as the stirrups that might be needed here for the top and bottom bars. The other thing that you're going to be seeing is going to be our design strips. So if I go ahead and look at my design strip, I've drawn in design strips from center to center point, but if we remember that this is actually overlapping at that point, so those beams are submeshed directly to the slab. But since I have a design strip defined directly to the center line, there's just a bit of an overlap between those elements. So it's not something to worry about, but if you had reinforcement, specifically highly reinforced beams, you may not need to have that design strip drawn directly to the center line because you already have accounted for all those forces at that location. So you could go ahead and delete that design strip and draw it a little differently here. This would be something you'd want to make your own modeling decision based on how you think the flow of the forces are working in your slab foundation structure. But I'm going to go ahead to show you as a demonstration. We're going to turn on the drawing grid so that it's easier for us to draw this in. So I've changed my drawing grid, and then I'm going to draw in that design strip. So the design strip's going to go here, and you might just hold it back a bit. So I'm going to hold that design strip slightly back from the edge. Now how far back? That's again going to be another one of those engineering judgment decisions that you will have to make when modeling in your design strip. I just sort of went with 2 feet to account for maybe the depth of that beam. So when I do my reinforcement design here, it'll just show me that it's slightly held back. Now that doesn't change the flow of my forces, just the reinforcement design. Another thickened slab method for using this type of a model would be to go ahead and use the tool thickened slab. So I'm going to go and jump into the new model here, and it's the same geometry here, but what we'll see if we look at its rendered view really quickly and then isometric, the way I modeled this model is that I have a thickened area around the perimeter slab. So that slab right here is a 36-inch slab that represents the beams in my previous model. And then what I did is I thinned the slab here in the interior, so I use with my tool here. I can see this thickness if I go to my slabs in the data entry spreadsheets, so I can use an 8-inch interior to modify that slab so that the outside is thick and the inside is thin. Now, one of the other things when I do that is I use reinforcement design strips a little differently. So I drew the design strip here directly to the top of the slab where that thickened area is all around, and the interior area I use a different design strip. So it would be designed based off of that depth there. So when I run this model, I'm going to see here, I'm going to get reinforcement design based on that information now. It's not exactly the same reinforcement as the thickened area because it's not considered a beam. However, I do really like the way the flow of the forces work because of the thickness of the slabs. This is an all-plate model, so you might end up with a little bit of a nicer transition in those slabs, although we're not getting stirrups in those beams. So depending on what your reinforcement needs are, you might want to do those stirrups outside of the program or decide to go with the model option using the beam method. At this point, we've completed the design and analysis of our thickened slab on piles.